Alright everyone, welcome back to another video here. So these are the quadratic equations that start on page 29. Now, the nice thing is I'm actually going to try to solve these as many different ways as possible. You'll have learned all three ways to solve a quadratic equation. So I'll be just kind of condensing things here, but that's how this will work. So for this next one, 6x squared plus 8 equals 128. Notice that there's no middle term. Now, what that means is, well, theoretically we could factor, but the best way to do this is to move that 8 over to the other side. So we'll have 6x squared equal to 120. And then when we divide out by the 6, we'll have x squared equal to 20. So then we take the square root of both sides, so x will equal plus or minus the square root of 20. Now, you should probably be able to figure out that 20, square root of 20, breaks down into root 4 and root 5, or simply plus or minus 2 root 5. So that's going to be the solution. Since there was no middle term, we can do it that way. Now the other way, using the quadratic formula. So what I mean by that is we'll move this 128 over. So 6x squared plus 8 equals 128. So we'll take away 128 from both sides, and what's going to happen then is we'll have 6x squared minus 120 equal to 0. Now, if you notice, we could actually factor something out of this. Because if we were to factor this using the quadratic formula, if we were to solve this using the quadratic formula, here's what would happen. A would be 6, B would be 0, C would be negative 120. And I've said this in class and I'm going to say it again. The first thing you always do when solving a quadratic by using the formula, figure out the discriminant, b squared minus 4ac. So it'll be 0 squared minus 4 times 6 times negative 120, which in turn will give us a value of 2,880. So then we would have to simplify 2,880. Now the problem with simplifying the square root of 2,880, it is a huge number, but what that will simplify to is 24 times the square root of 5. So what we can then do is we can use the quadratic formula. Now again, I've said this before, I will give that to you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So by plugging everything in, you'll have negative 0, which is just 0, plus or minus 24 root 5. See how we're saving a few moments? We don't have to figure that out again because it's already done. That'll be 2 times 6. And what will happen is you'll have plus or minus 24 root 5 over 12, which does simplify. If the 24 and the 12 get divided out, it'll just be plus or minus 2 root 5. Now, with the quadratic formula, figuring out the square root of 2,880 was quite a bear. Now, the third way you could actually do this, if we go back to doing 6x squared minus 120 equal to 0, we could actually factor a 6 out, giving us x squared minus 20 equal to 0. And if we divide out by the 6 right now, you'll just have x squared minus 20 equal to 0. So A will be 1, B will be 0, and C will be negative 20. So in figuring out the discriminant, 0 squared minus 4 times 1 times negative 20, that's going to give us 80. And the square root of 80 is going to simplify to square root of 16 times the square root of 5, or more nicely, 4 root 5. So using the quadratic formula once again, negative 0 plus or minus 4 root 5 over 2 times 1, that's just going to give us plus or minus 2 root 5. So, am I going to make you show me all these ideas here? No. Thing is, with the quadratic formula, if you can factor something out, by all means do it, because we're solving an equation. Alright, so we have another equation to solve here. 6x squared minus 36 will equal to negative 12 minus 12x. So I'm going to demonstrate all three methods on how to solve this. First, we'll add the 12 and we'll add 12x to both sides. Since there was no middle term to begin with, what we're left with here, let me rewrite that a bit. We'll have 6x squared plus 12x minus 24 equaling 0. Now, I could do this completing a square or whatever way, but if you notice, we could take a 6 out right now, so why not do it? So we'll have 6 times x squared plus 2x minus 4 equaling 0. And then when we divide out by 6, we are going to have simply x squared plus 2x minus 4 equal to 0. So, what I'm going to do is I'm going to first use the quadratic formula. So for that, a will equal 1, b will equal 2, c will equal negative 4. So b squared minus 4ac, that's going to give us 2 squared minus 4 times 1 times negative 4, which, if you just punch that up in your calculator, that is simply going to be 20. Now, here's the thing. Earlier on, we established that the discriminant, in order for it to be factorable, would have to be a perfect square. Well, factorable over the integers. So this will not be factorable, because 20 is not a perfect square. But if we simplify square root of 20, that will become 2 root 5. So if we just go ahead and continue on with the quadratic formula, negative b, that will be negative 2 plus or minus 2 root 5 over 2 times 1. And that'll just be negative 2 plus or minus 2 root 5 over 2. So you could actually write this as, negative 2 over 2 plus or minus 2 root 5 over 2. But the purpose is, we're going to have some removals here. This will be negative 1 plus or minus root 5. So those are going to be the two solutions. So what'll happen now is I can solve this by completing a square. And I'm not going to start off with the very original equation. We'll have x squared plus 2x minus 4 equal to 0. So we'll just move that 4 to both sides by adding 4 to both sides, plain and simple. So we'll have x squared plus 2x equaling 4. Now, what is going to complete the square? Well, half of 2 is 1. 1 squared is 1. So when we factor this, it'll just be x plus 1 squared equal to 5. By taking the square root, x plus 1 will equal plus or minus 5. We can just move that 1 over. X will be negative 1 plus or minus 5. Now, I said that this is not factorable over the integers. Like, you will not get any kind of solution that you can factor out of this. But the interesting thing that will happen is, if you were to factor this, it would be x minus, forgot to redraw my radical here, negative 1 plus root 5, x minus negative 1 minus root 5. And you'd get x plus 1 minus root 5, x plus 1 plus root 5. But here's the thing, this factored form that you see here, you will never, ever be forced to do that. I've never done it in all my higher levels of math, and believe me, I've done a lot of it. So we don't need to worry about that. Alright, so we've got another one of these to solve. Now this one will add 12x to both sides. So what will happen here is we'll have negative 7x squared plus 12x minus 2 equal to 0. So we're going to go ahead and solve this using both. We're going to go ahead and solve this using using all three methods that we know. So if we want to use the quadratic formula, we know that a is negative 7, b is 12, and c is negative 2. So b squared minus 4ac is going to be 12 squared minus 4 times negative 7 times negative 2, and we're going to get 88 out of that deal. So square root of 88 will simplify into root 4 times root 22, and it'll just be 2 times the square root of 22. So now we can take the route of the quadratic formula. We'll finish up the formula. So negative b, that'll be negative 12 plus or minus 2 root 22, all over 2 times negative 7. Negative 12 plus or minus 2 root 22 over negative 14. So we'll have negative 12 over 14, negative 14 rather, plus or minus 2 root 22 over negative 14. Well, it's not going to matter here because it's plus minus, but this will be 6/7 plus or minus square root of 22 over 7. Or you can recombine it into 6 plus or minus square root of 22 all over 7. So you could do it that way. Now, completing the square is going to be a fun one for this, but it's doable, like all of our problems. If we have negative 7x squared plus 12x minus 2 equal to 0, we're going to divide out by negative 7. We're going to divide every single term by negative 7. And that gives us x squared minus 12/7 x plus 2/7 equals 0. And then we'll have x squared minus 12/7 x equals negative 2/7. So yeah, I had to just make some room over here. That's why I paused. So what are we going to add to both sides? Well, 1/2 of negative 12/7 is negative 12/14 or negative 6/7. Negative 6/7 squared is 36/49. So that is what we are going to add to both sides, 36 over 49. So the nice thing is this will just factor into x minus 6/7 quantity squared equal to, so this other side will equal to 22/49. So that's when we take the square root of both sides, and we'll have x minus 6/7 equal to plus or minus, square root of 22 doesn't simplify, so just have 22, but the square root of 49 is simply 7. So x will be 6/7 plus or minus square root of 22 over 7, which magically is the same thing here. Now again, you don't have to do all three methods if applicable, but the reason I'm showing this to you is, it works. This gives you extra practice. Alright, so this next one is going to be we're going to do this one using quadratic formula and completing a square and factoring. We couldn't factor that previous one, by the way, because if the discriminant is 88, the discriminant has to be a perfect square. So what we got here now is negative 5x squared minus 4x plus 5 equal to 0. So let's figure out the discriminant. Negative 4 squared minus 4 times negative 5 times positive 5. And that's going to be 116. And since that is not a perfect square, if you take the square root of 116, it's not a perfect square by any means, so it will not be factorable. If we took the square root of 116, that would simplify into something. It will be 2 times the square root of 29. So if we plug the rest of this stuff in, it'll be 4 plus or minus 2 times the square root of 29 over 2 times negative 5, which is negative 10. So 4 plus or minus 2 root 29 over negative 10. We can either split that up or, so 4 over negative 10 plus or minus 2 root 29 over negative 10. It doesn't matter for the second part here, but that's negative 2/5 plus or minus square root of 29 over 5, or negative 2 plus or minus the square root of 29 all over 5. So I'm going to do completing the square. So we'll have negative 5x squared minus 4x plus 5 equal to 0. We're going to move that 5 over because, remember, for completing the square, variables have to be on one side, constants have to be on the other. So that'll be negative 5. And notice here I did this a little bit differently in order. I could have divided up everything by negative 5 first, but it doesn't matter because it all works out the same. I have to divide out by negative 5. So I'm going to do that. I'll have x squared plus 4/5 x, and I'm going to leave a spot over here, and that'll be negative 1. So what do we have to add to both sides? Well, 1/2 of 4/5 is going to be 2/5. And 2/5 squared is going to be 4/25. Oh, I made a mistake here. Negative 5 over negative 5 should be positive 1. But nonetheless, we are still going to add 4/25 to both sides. So this will factor into x plus 2/5 quantity squared, and that'll equal 29 over 25. Hey, that should seem kind of familiar. So we'll take the square root of both sides. You'll have x plus 2/5 equal to plus or minus the square root of 29 over 5. And ultimately you'll end up with the same exact solution. Moving along. Alright, so we'll move on to another example, and so we're going to add 7 to both sides here, giving us 6x squared plus 5x, negative 63 plus 7 should be negative 56, and that will equal 0. So let's figure out the discriminant here. 5 squared minus 4 times 6 times negative 56, and that is going to equal 1,369. Now, if you were to take the square root of 1,369 in your calculator, you would get 37. So here's a nice thing. This will be factorable. But let's finish this up with the quadratic formula, completing the square, and we'll do the factorization. Ho hum, that's going to be fun. So negative 5 plus or minus 37 over 2 times 6, that's negative 5 plus or minus 37 entirely over 12. So, you could do this two different ways. You could split it up. Negative 5 plus 37 is 32. 32 over 12. That will simplify to, if I divide by 4, that'll be 8 over 3. Negative 5 minus 37 over 12 gives you negative 42 over 12. If I divide by 6, that'll equal negative 7 over 6. Of course, you have negative 5 twelfths plus or minus 37 twelfths. It yields the same exact solution. Either way, okay, sorry about that. Basically, yeah, it should be negative 7 over 2. So that's what we got. I forgot it was recording this whole time. Oops. Oh well. So basically, we'll have negative 7 halves and 8 thirds for our solution. Now, let's complete the square. So we'll just have 6x squared plus 5x, and we'll just take this here and we'll move the 56 over right now. We'll divide out by 6. So we'll have x squared plus 5/6x equals 56 over 6, which, you know what, it's no big deal if you want to simplify it now or later, but it would be 28 over 3. So what is going to complete the square here? Well, half of 5/6 is 5/12. And 5/12 squared is 25/144. So that is what I'll be adding to both sides. And so this will factor into x plus 5/12 quantity squared, and 28 thirds plus 25/144. That'll give you 1,369 out of 144. So when we square root both sides of this bad boy, what happens is you'll have x plus 5/12 equal to plus or minus 37/12. So basically, x will equal negative 5/12 plus or minus 37/12. And it yields the same solutions here. Pretty neat. We're now going to do we're going to solve this with factoring now. And that's where, yeah, if I gave you something this big, I probably wouldn't have you factor it anyway. 6x squared plus 5x minus 56 equals 0. I need two numbers that have a sum of 5 and a product of whatever 6 times negative 56 is. And the product is going to be negative 336. So the two numbers that we need, since the sum is positive 5, it'll be 21 and negative 16. So we'll factor by grouping here. I'm going to kind of wall this off a little. So we'll get 6x squared plus 21x minus 16x minus 56 equal to 0. And, yeah. So what I'll do is I'm going to take a 3x out of this. So 3x, that'll be 2x plus 7. And let's see, I think I can take an 8 out. Yep, 8. That'll be 2x plus 7 equal to 0. So now I'll have 2x plus 7 times 3x minus 8 equal to 0. So if 2x plus 7 equals 0, 2x equals negative 7, x equals negative 7 halves. 3x minus 8 equal to 0, 3x equals 8, x will equal 8 thirds. So we were able to factor because, factor over the integers. So there's 3 ways to do this, and I will tell you which way to use. So we figured out the discriminant here, and what we've learned is it is not factorable because if you took the square root of 480 in your calculator, you'll get some irrational decimal. But if we take, the square root of 480, I know 16 goes into that. Oh, and 30 doesn't simplify, so root 16 times root 30, and that'll just be 4 times the square root of 30. So for the solution using the quadratic formula, we'll have 6 plus or minus 4 root 30 over 2 times 1. Or, 6 plus or minus 4 root 30 all over 2, and you can do it individually, but you will get 3 plus or minus 2 root 30, which I didn't formally mention earlier, but all these solutions with radicals are going to be conjugates of each other. Now, let's do completing the square. X squared minus 6x, and I'll just cut to the chase. That'll be equal to 111. Half of 6 is 3 squared, or negative 3, and that'll be a 9. So this will be x minus 3 quantity squared equal to 120. We take the square root of both sides. X minus 3 will equal plus or minus the square root of 120, which will be plus or minus 2 root 30. And we can just move that 3 over. X will equal 3 plus or minus 2 root 30. And of course you can write them individually if you so wanted or not. All right, 2 more quadratics. All right, so this one is already set equal to 0, so let's do the discriminant. I always like to do the discriminant of quadratics, whether or not I tell you to complete the square or factor. It takes just a minute. Negative 3 squared minus 4 times 20 times negative 9. We figure out that discriminant, and it is going to be 729. And if you take the square root of 729, you're going to get 27. So this will be factorable, and that's going to be fun to factor, but it is factorable. But let's get back to the problem at hand. So using the quadratic formula, negative b, which will be positive 3 plus or minus 27 over 2 times 20, which is 40. So you'll have 3 plus or minus 27 over 40. So 3 plus 27 over 40 would be 30 over 40, which becomes 3 over 4. And 3 minus 27, that would be negative 24 over 40. If we divide by 8, that would be negative 3/5. So we have our 2 solutions right here. Now, let's complete the square. Let's just move that 9 over, so 20x squared minus 3x, and we move the 9 over right now because we're going to divide everything out by 20. And the nice thing is, this will come out very nicely. So you'll have x squared minus 3/20 x equal to 9/20. So since I have some room down here, half of negative 3/20 will be negative 3/40. And negative 3/40 squared will be 9 over 1600, 9/1600ths. So we'll add 9/1600ths to both sides. So the nice thing is this will factor into x minus 3/40 quantity squared, and we figure out 9/20 plus 9/1600ths, and we get 729 out of 1600. So when we take the square root of both sides, we'll have x minus 3/40 equaling square root of 729, which is 27. So this will be plus or minus, rather, 27/40. So we can move that 3/40 over. 3/40 plus or minus 27/40. So you'll get the same answer regardless. Alright, so now we can do this by factoring, and I said it's factorable because the discriminant was in fact a perfect square. So 20x squared minus 3x minus 9 equal to none other than 0. So I need two numbers that have a sum of negative 3 and a product of negative 180. So the two numbers, 15 and 12. Well, negative 15 and positive 12. So we'll have 20x squared minus 15x plus 12x minus 9 equal to 0. Then we factor by grouping. I can take a 5x out of this. That'll be 4x minus 3. I can take a 3 out here, giving us 4x minus 3 again. So 4x minus 3 times 5x plus 3 will equal 0. So we set each of those equal to 0. 4x minus 3 equal to 0. X will equal 3/4. No surprise. 5x plus 3 will equal 0. 5x will equal negative 3. X will equal negative 3/5. So those are the two solutions. I've reiterated that a few times. All right, we have one more quadratic. All right, so for this last one here, now, disclaimer, I will not give you anything this big on a test. If we do 16x squared minus 160x plus 355 equal to 0, if I want to figure out the discriminant, that'll be negative 160 squared. This is already going to be very ugly. 4 times 16 times 355. So if we figure this out, it's going to be 2,880. If you look back, 2880 was the discriminant for that very first problem. So we know that will become that'll become 24√5. Nonetheless, if we take the square root of 2880, and that becomes 24√5, this is not factorable. So we'll have 160 plus or minus 24√5 over 2 times 16, which is 32. And what we'll be left with here is, we can cancel some things out. 160 over 32 plus or minus 24√5 over 32. Now the nice thing is 160 over 32 is just 5. 24 over 32 would be 3/4, 3 root 5 over 4. So those are the two solutions for this one. Now, if I wanted to complete the square, that's going to be more fun, but it is doable, just like all these are. So what will happen is 16x squared minus 160x. Let's move that 355 over right now. And let's divide everything by 16. Now, here's the nice thing. We're actually going to be able to just simply add an integer to both sides. You have x squared minus 10x equal to negative 355 sixteenths. So half of negative 10 is negative 5. That squared, negative 5 squared, is positive 25. So we'll have x minus 5 quantity squared equal to whatever negative 355 sixteenths plus 25 is, and that would be 45 sixteenths. Using the calculator. Trust me, you want to use the calculator. So we take the square root of both sides. X minus 5 will equal plus or minus square root of 45 over 4. But the square root of 45 becomes 3 root 5. And you can just move that 5 over, and there you have it. So that is how we do these quadratic equations. Now again, this was real overkill, but I like to drive the point home. Now stay tuned, we've got some square root equations. Alright, so if you go to, I believe this is page 32. I'm going to do these last two radical equations. Now I'll have a video for P9 at another time, some P8 examples. We got to get the radical by itself first. So we'll add 5, and so what will happen is we'll have the square root of 5x plus 61 equal to x plus 5. Now we're going to square both sides and get rid of that radical. Now I'm going to be drilling this to you in class, but 5x plus 61, you will have to be able to FOIL this out, and what will happen is it'll be x plus 5 times x plus 5, or x squared plus 10x plus 25, and that equals 5x plus 61. Now, we need to get everything over to one side, so I'm going to take away 5x and 61 from both sides. So we'll have 0 equal to x squared plus 5x, and that is 25 minus 61, which is negative 36. Now, these radical equations will always be, the radical equations will not have radical solutions, because don't worry about that. So what will happen here is this will factor into x plus 9 and then x minus 4. So x will equal negative 9, x will equal 4. Now the thing is, we have to enter each of these into the original equation as it's written before we can actually, because that way we might have an extraneous solution. So in checking negative 9, we'll have negative 5 plus the square root of 5 times negative 9 plus 61 equal to negative 9. Negative 5 plus the square root of 16 equals negative 9. Obviously, this is no. So x equals negative 9 is what we call extraneous. Now, if we check x equals 4, that will be negative 5 plus the square root of 5 times 4 plus 61, and that should equal 4. Negative 5 plus square root of 81 will equal 4? That's yes. So the only valid solution is x equals 4. You can guarantee you will see one of these on your test and one of these will be extraneous. So be ready for that. All right, the very last example for this, we need to get everything over to one side. So I'm going to subtract 2x and add 6 to both sides. And what we're left with is x minus 1 equal to the square root of 5x minus 5. So then I'm going to square both sides here by FOILing. You have x squared minus 2x plus 1 equal to 5x minus 5. And then what we'll do is we'll take away 5x and add 5 to both sides. Negative 5x plus 5. And we will have x squared minus 7x plus 6 equal to 0. This will factor into x minus 6 times x minus 1 equal to 0. We'll get x equal to 6 and x equal to 1. Now, here is what I'm going to do I'm going to actually verify this on the calculator, show you how to do this. So what I'm going to do is, I'm also going to put the screenshot on here. So what I'm going to do is, I'm going to, obviously test this one by one. We're going to let x equal to 6. And I'm going to enter these sides one by one. 3x minus 7, and that will give me a value of 11. Now, if I type in exactly what is on the other side, that is 2x plus the square root of 5x minus 5. 5x minus 5, and afterwards is the negative or minus 6. What happens is we get 11 here. So with that screenshot in there, that goes to show that 3x minus 7 and the other side both equal 11. Now let's see if the same thing happens when x is 1. So we're going to store 1 into x, and we'll do 3x minus 7, and we're going to get negative 4. It's not looking good. 2x plus the square root of 5x minus 5, and don't forget the minus 6. Whoop, that should be minus 6. And, oh, it's negative 4. So, the neat thing is, both solutions ended up working for us. So, when all is said and done, neither one of these two solutions is extraneous. Had some editing issues here. So, in other words, both solutions were valid. No extraneous solutions. So, just for a laugh, I put a screenshot of the TI Inspire just to show you that that worked. Alright, so that is this video. I know it's a little long. It's probably about 5 minutes longer than it should be because I didn't realize I was recording when I was doing something else. Something else came up. So, yep. So that's it, and happy viewing.